hydrogen production methods, there are a few different ways that hydrogen is produced. I will be going over how fossil fuels are used to produce hydrogen. Laken will be going over how water is used, and then Peyton will cover the case studies for this project. So in terms of fossil fuel methods, there's a plethora of different ones. We only picked a few just because of the allotted time. So we'll go over steam methane reforming, partial oxidization, plasma reforming, coal, and depleted oil wells. So steam methane reformers are the most common. 50% of the world's hydrogen is produced from steam methane reformers. It's very inexpensive and also extremely efficient. This is when hydrogen is produced from water and natural gas, which is mostly methane, and it's achieved by heating that gas to a super high temperature while also having a nickel catalyst and steam present. And then when the methane and hot steam react together, it creates an endothermic reaction that produces a product called syngas, which is shown in the left equation. After the syngas has been generated, more hydrogen can be obtained by an exothermic reaction in the presence of a lower temperature, as shown in the right equation. Partial oxidization is another method. This is when a fuel air or fuel oxygen mixture is combusted, known as a substoichiometric reaction in a reformer or partial oxidation reactor. After this chemical reaction takes place, it's modeled in the left equation. And then, so for example, say if you had C12H24, you would use that base equation to figure out what your desired equation would be given the elements. Plasma reforming is also another method. In the 1980s, the Cavenner process was created and focuses on the splitting liquid hydrocarbons into black carbon and hydrogen, and it is 48% hydrogen once it's been split. Coal is another important method. Coal gasification is the main use for producing hydrogen with coal and takes place when oxygen and steam break the molecular bonds that make up the coal. When this happens, it yields a carbon monoxide and hydrogen mixture, and then the pollutants can be removed much easier when implementing this method. Another one that I won't go into detail but will mention is the low or high temp coal carbonization. And lastly, depleted oil wells. This was probably my favorite just because this unusable oil has no purpose, and once you inject that unusable oil with microbes, you can get the hydrogen out of that. It's very efficient and it's also inexpensive and nothing but profit, as like I said, the unusable oil wouldn't be used for anything else.
The two main renewable hydrogen production methods that can be applied to the manufacturing setting include electrolysis and thermolysis. Electrolysis splits water through the application of direct current. As water passes from the anode to the cathode, hydrogen is produced. To increase efficiency of the electrolysis, electrolytes can be added. Currently, 5% of the world's hydrogen gas is produced through electrolysis. Thermolysis creates hydrogen through the dissociation of water at temperatures exceeding 2500 Kelvin. To withstand such high temperatures, high-cost equipment is required. Catalysts can be added to decrease reaction temperature, but will introduce corrosive reagents to the equipment. Since the catalysts are contained in a closed loop, thermolysis systems should only need a water source to run. Combining thermal and electrochemical reactions together lower the maximum operating temperature required for the dissociation of water into hydrogen and oxygen. The addition of copper and chlorine to the copper chloride hybrid cycle reduces the maximum operating temperature to 500 degrees Celsius, reducing equipment costs.
In the past couple decades, hydrogen usage has increased dramatically. In 2020, 10 governments implemented strategies through 228 unique projects. Through these, electrolysis accounted for 70 megawatts of production. After all of this, 1.4% of the global energy fund was put towards hydrogen, which is about $300 billion worth. While this seems like a low percentage, it's a massive increase from previous years. Changes like this are expensive, so seeing this level of involvement shows how committed a lot of the world is to improving and cleaning up energy consumption. These global strategies resulted from purposeful hydrogen production, but it's much more difficult to find examples of companies utilizing hydrogen they produce as a byproduct. In 2015, Hanwha Total Petrochemical expanded its aromatic hydrocarbon production capacity at this facility, Daesan Industrial Complex in South Korea. From that, they began to notice excess hydrogen from their petrochemical manufacturing, about 3 tons per hour worth. Because the issue was newer, they had just been burning it off into the atmosphere. They had previously implemented a no combustion, no air pollution policy to reduce carbon emissions, so they recognized that this is bad for the environment and looked to Hanwha Energy to look for solutions to put the hydrogen to use. Hanwha jumped in and partnered with Korea East West Power and Doosan Corp to establish Daesan Green Energy, a company specifically for this project. By 2019, they built a $212 million plant with 114 fuel cells occupying 20,000 square meters. Fuel cells combine hydrogen and oxygen while only emitting heat and water vapor, cutting carbon emissions from alternatives such as fossil fuels. From the fuel cell plant, 120,000 metric tons of water vapor is emitted yearly and is condensed and pumped back into Hanwha Total Petrochemical, making a near zero waste operation. While $212 million is a massive amount of money to invest, it is clear that this decision was a success and the company will reap the benefits, both financially and environmentally, for years to come.
Hydrogen generation is not common in the manufacturing setting currently. With the prevalence of waste heat emitted from manufacturing processes, hybridization of water splitting techniques can be used to decrease the release of waste heat while also generating plants a profitable byproduct. Currently, the iron and steel industry account for a large portion of the waste heat released into the atmosphere. Most of the heat from the industry exceeds 500 degrees Celsius and can be used to produce hydrogen. Here's our references.
And that's it.
All.